Find the equation of the tangent line to the curve y equals sine squared x at the point pi over 4, 1/2. All right. So the first thing I want to do is I want to write this sine squared as sine x squared, like that. And the reason I want to write it that way is so that you can see the chain rule being applied. Remember, the chain rule is you want to take the derivative of the outer function. So in this case, the derivative of the outer function is something squared. Y prime would equal, bring the 2, multiply it to the 1 as the coefficient. So 2 times 1 is 2. Rewrite sine, and then decrease the power of 2 by 1. But then we have a function on the inside, so the inner function, we want to take the derivative of that, and the derivative of sine is cosine x. So there is our first derivative. Now let's just clean it up just a little bit. Get rid of the parentheses because the sine x is raised to the first power. So I could just write this as 2 sine x times cosine x. And some of you may realize that that is the double angle for sine. And so we could write this as y prime is equal to sine 2x. Now, it is helpful to know the double angle formula for sine, but for this problem in particular, we could get around doing this problem without knowing that. All right. So remember, the goal is to find the equation of a tangent line. And so to find the equation of a line, we need a slope and a point. Well, we're already given a point. That's the point that we want our tangent line to pass through. We need the slope. And so remember, the derivative calculated at a certain point gives you the slope of the tangent line at that point. So we need the slope of the tangent line at the point x equals pi over 4. So what do? We take pi over 4, we plug it into the first derivative. So if I take pi over 4 and plug it into y prime, I'll have sine of 2 times pi over 4, which is equal to sine of pi over 2. And we want to find sine of pi over 2. So let's just sketch a unit circle. We don't have to sketch the whole thing, obviously. We just sketch, think about where pi over 2 is. Pi over 2 is the 90-degree angle. So here's pi over 2. Remember, that exact value on the unit circle would be, we didn't go any left or right, so 0. We went 1 up, so 1. Remember, sine is the y value at an angle. So sine at pi over 2 is equal to 1. Slope. The slope of the tangent line is m equals 1. The point is pi over 4, 1/2. So I like to use point slope form first because all we need is a point and a slope to find the equation of a line. And then if we were asked to express that in slope intercept form, which is the more commonly equation of a line that gets used, we just solve for x. So point slope form looks like this. Y minus y1 is equal to m times x minus x1. x1 and y1 are just the point at which we're trying to pass through. And then of course, m is your slope. So let's plug in what we know. We know our x1 is pi over 4, our y1 is 1/2, and our m is 1. So let's plug those in and we'll get this. Just like that. Now, if I wanted this in slope intercept form, I want to isolate y, so I would have to distribute the 1, right, which is going to be easy, but then also move over that 1/2. So it'll look something like this. There we go. Y is equal to x minus pi over 4 plus 1/2. Now you could, if you'd like, you could combine those two constants with a common denominator. Either way is fine. Let's combine them. That way we can see what the y-intercept would be if we were trying to plot this tangent line. So if we combine those with a common denominator, that denominator would be 4, and our equation of the tangent line would look like this. There we go. So to get that, just to show you, I would multiply this fraction 2 and 2, top and bottom. So that's where the 2/4 is coming from. And I just put the minus pi at the back because it looks a little nicer. And that is the equation of the tangent line. We can plot that in our calculator, sine squared x, and then plot that line there. And notice that it will be tangent to the curve of y. On to the next one.